Okay, I want to start another video. Previous problem we had irreducible. Here we have repeated factor. So the hard part of the problem is figuring out where does this fraction come from. We're going to say that is x plus 2. Remember, you have to list that as many times as you see multiplicity. If this was a cube, you would list that again. This is linear. This is not linear, but you could write it as the product of linear factors. It counts as linear, and that's linear. Get rid of parentheses, get rid of the fractions, multiply with the LCD both sides. And one value we can get really quickly, and that is the domain here, x cannot be -2. Let x equal -2. Again, this is my equation. Read the left. 2 equal x equal a 2. That's a 0. That's a 0. If I put a 2 in there, c equal 2 plus 2 is 4 squared. That's 16. So that means c equal 2 over 16 or 1 over 8. Let x equal -2. What would happen? 2 equal a -2 there will make that a 0. B, a -2 there, 2 minus a -2 is 2 plus 2. And a -2 there will make that a 0. By the way, that is 1/8. So if I have 4b equal 2, b will be 1/2. And now that I did use everything in the domain, since 0 is not in there, let x equal 0. I'll be looking at 2 equal a. If I put a 0 there and there, that is 2 times 2, 1/2. If I put a 0 there, that's a 2, 1/8. If I put a 0 there, that's 2 squared. Figure out what this value is, and pretty much you're done. Well, 2 equal 4a plus 1. That's 4 plus a half. Or 2 equal 4a plus 3/2. I could say 4a equal 1/2. When you subtract 3/2 on both sides, multiply by 1 over 4, and I just figured out what a is, and that's the hard part of the problem. Now be careful, not every fraction translates into a log. So only the linear. This is the integral of 1 over 8 over x plus 2 plus 1 over 2 x plus 2 squared plus 1 over 8 over 2 minus x dx. This will be 1 over 8 natural log of absolute value of x plus 2. This will be 1/8 natural log of 2 minus x, but if you let u equal, or if you take a derivative of that, you multiply by -1. Dividing by -1 and multiplying by -1 has the same result. This piece plus 1/2, I'm looking at an integral of dx over x plus 2 squared. If you let u equal x plus 2, du is simply dx. That becomes simply an integral of du over u, which is u to the -2 du. Add 1 to the power, divide by that, and that will be -1 over u, and u in our case is x plus 2. Don't forget the plus c, and everybody's happy. So this is what this section offers. Now, these are going to start coming up now that you know about them a lot more than you like. So we're glancing at the following problem. Well, that doesn't look like a composition at all. except I look at that, I say, okay, if I let u equal e to the 2x, derivative of e to the 2x is e to the 2x, that doesn't work. If I let u equal the whole denominator, doesn't work. I'm going to start thinking ahead a bit. Remember, I want my derivative to be e to the x. I want to let u equal a quantity, where when I take a derivative of that, I get some form of e to the x dx, yeah? So I could put a du there. Well, guess what? What do you take a derivative of to get e to the x? E to the x. If I let u equal e to the x, wouldn't that be e to the 2x? Isn't that e to the x squared? That will be e to the x squared, 36 minus that. And this is my u. So, and if I let x equal 0, e to the 0 is 1. And if I let x equal 1, that will be e. Okay, now what? Well, now I'm going to go on the side and say, look, how quickly can I figure out where this comes from? If we use bugging you could use different letter. Let u equal 6. 6 plus 6 is 12. 6 minus 6 is 0. So a is 1 over 12. And let u equal negative 6. We're looking at 1 equal a negative 6 there, that's a 0. Negative 6 minus 6 is negative 12, which means b is negative 1 over 12. So I know this is going to be 1 over 12 natural log of 6 minus u divided by a negative minus 1/2 natural log of 6 plus u. Evaluate from 1 to e. Put e in. That will be negative 1/2 natural log of 6 minus e minus 1/2 natural log of 6 plus e plus minus, not plus, minus, put the 1 in for u, negative 1/2 natural log of 5 minus 1/2 natural log of 7. There's my answer. Similarly here, I look at this, I let u equal the inside of the power function, in our case cosine. Du is negative sine of x dx. And again on the side, take 1 over 1 minus u. If I distribute the negative in, that will make it du over u squared minus 1. It's easier that way. So let's take 1 over u minus 1 into u plus 1 over u minus 1 u plus 1 a and b. So 1 equal a into u plus 1 plus b into u minus 1. There it is. Well, two values. Let u equal negative 1. One equals 0 plus b times negative 2. So b is negative 1/2. And let u equal 1. 1 equal a times 2. And if you put a 1 there, plus 0. So this is 1/2. So I know this is 1/2 natural log of u minus 1 minus 1/2 natural log of u plus 1. Now put u back in and everybody's happy. And no need to simplify that in any way. It's good as it is. You could factor the 1/2 out. You could combine the tables into one. You could do a lot of things. Well, now that we are really comfortable with this, let me set up the next couple of problems. Here I have many options. I see a radical, but there's no square in there. Well, I would let u equal, it's up to you. Either you let it be the whole denominator, or you let it be just the radical part. I suggest you stick just with the radical part for now. That turns out to be quicker, but it doesn't really matter. Well, here, I know if I take a derivative, I'm in trouble, because there is no 1 over twice the square root. So what I do, I square both sides. I add an extra step in there. Why is that? Because, hey, I'm letting u equal that. I want du to have no radical. Now if I take a derivative, 2u du equals simply dx. I want dx to have no radical. Dx, I'm going to replace by 2u du. 1 minus u, 1 plus u. This is twice the integral of negative u squared. I should say u minus u squared divided 1 plus u du. Well, what's the deal? This is an improper fraction. The way we work around it, we say, look, take. So I'm going to factor a minus out just to make this simpler. Divided by u plus 1. U squared divided by u is u. Multiply. Subtract. Divide. So now I have just figured out that this is the quotient, and the remainder is 2 divided by the u plus 1. And I know what that is. Add 1 to the power, divide by that. And if I distribute the 2n plus 4 minus 4 natural log, and what was u, plug that in and we're done. And that was marked in yellow. That was the square root of x. You could simplify, you really don't have to. And there's my final answer. Okay, looking at the next problem again, I have a couple of options. One way of looking at this is to let u equal either e to the x or 1 minus e to the x. It doesn't really matter. And I'll show you both cases. Now the issue is if I take a derivative, either way, I get e to the x dx, which is a problem because there's a 1 plus there. But by letting u equal this, I need du to be e to the x free, even if you split this up, even if you say that is 1 over 1 minus e to the x dx, plus the integral of e to the x over 1 minus e to the x dx. You could do that with this problem, and say here, let u equal e to the x, du will be e to the x dx. That will work on this piece, but that will be an issue for this piece. Here you're going to have to come and do the problem the way we're going to do it for the whole thing, so might as well. Since this piece cannot work, might as well. And sometimes you have to do this option. You say, look, if I take a derivative, that's not going to work. What I have to do, I have to make sure that when I take a derivative of e to the x, when I take a derivative of du, it should be just be dx. Well, how is that? Well, I can solve this equation and say natural log of u equal x. And now if I take a derivative of this, I have a dx. That would be 1 over u du. Well, in this case, that's the integral of the yellow part. The blue part, and if you really think of this, that's the integral of u plus 1 over u into 1 minus u du. And if you'd like to factor a minus 1 out, if you like, that would look like this. Well, here you're going to say that is u plus 1 over u into 1 minus u is a over u plus b over 1 minus u. Get rid of the fractions. Let u equal 0. 1 equal a times 1. A is 1. Let u equal 1. 1 plus 1 is 2. 0 plus b. And there it is. Basically, my answer is simply negative. So I'm integrating this instead. Negative natural log of absolute value of u minus twice natural log of 1 minus u plus c. U was e to the x, if you recall. Of course, these undo each other. You're really looking at negative x minus twice natural log of 1 minus e to the x plus c. I would like to remind you, when I wrote this as the integral of 1 over 1 plus e to the x dx plus the integral of e to the x over 1 minus e to the x dx, that right there was straightforward. Now, what if I would have let u equal this? Then I would have to solve for x. And here I would say dx is 1 over 1 minus u times negative du. And that integral would be 1 u times negative du over 1 minus u. And 1 plus e to the x is 1 plus e to the x is 1 minus u. So that is negative the integral of 2 minus u over u into 1 minus u du. You proceed and work out this problem and you'll end up with the same answer. Couple of more problems. I said I was going to set them up, but get excited. If you ever see multiple radicals, let u equal the largest radical. And again, I notice if I take a derivative, of this, I have a problem. So what I do, I would raise to the 4th power both sides, because I know there's only a dx. And now if I take a derivative of the right, that's dx. That is 4u du. And what is the square root of x? If x equal u to the 4th, square root both sides, that would be u squared. And that will be the integral of, let me put the 4 up front, I could factor a u out, and that is simply for the integral of du over u plus 1. That is for natural log of absolute value of u plus 1. Let me make sure there was no error. Let me just think about that for a minute. Let u equal the fourth root, raised to the fourth power goes up. Oh, 4u cubed. No wonder. I'm like, wait, if I take a derivative of that, that doesn't match. Look at that. My mistake. 4u cubed. And now if I square root both sides, I'll get u squared. That is true. This is an improper fraction, as we mentioned. Go on the side. Okay, I feel a lot much better. Take 4u cubed divided by u squared plus 1. Again, that's improper fraction. So here, that is 4u multiply 4u cubed plus 4u. Of course, you could subtract the 4 and just leave the u cubed if you want. Doesn't really matter. Subtract. So I'm left with 4u minus 4u over u squared plus 1 du. That is 4u squared over 2 minus 4, the integral of u over u squared plus 1 du. Let w equal u squared plus 1. dw is 2u du. We know this is twice u squared. There's my u. There's my du. So u was fourth root of x. I'm looking at twice the fourth root of x squared minus twice natural log of w. W is u squared plus 1, and u is the fourth root of x squared plus 1. And there it is. And this problem right here, again, I look at that, so wait a minute. I notice that there's an e to the x dx. I know already I'm going to let u equal e to the x because the derivative of that is e to the x dx. A lot of times you look at what's given and you know where to start. If I put that in there, that becomes the integral. There's my du. And there is my u squared minus 4 squared. And we know how this works. This is a bit longer. So this is 1 over u minus 2 into u plus 2 squares. That is a over u minus 2 plus b over u minus 2 squared plus c over u plus 2 plus d over u plus 2 squared. And you proceed. A bit longer than we like, but we don't have that many of those. One more to go. I think that's the last one. Yeah. Well, this one has a small trick. That's the integral of 1 over 2 plus 1 over e to the x dx. So if you clear the fractions, that's e to the x over 2 e to the x plus 1 dx. And if you let u equal e to the x, du is e to the x dx. Again, something we're going to start looking at before we start. If you let u equal e to the x, du is e to the x dx, and it's very important for you to replace things, otherwise you lose track of what is what. And that would be natural log of absolute value of 2u plus 1 divided by 2 plus c. And u was e to the x, so that would be 1/2 natural log of 2e to the x plus 1 plus c. Let me just make sure I didn't make a mistake. Well, I can check. Take a derivative. 1 over 2e to the x plus 1 times the derivative of that, which is 2e to the x. The 2's cancel out. And you're left with, yep, perfect, exactly that. Very good. So hey, no mistakes there. And that's pretty much it for this section.